This is Algebra 1, Assignment 3-3, problem number 8. Again, this is systems of equations, solving systems of equations by elimination, um, another word problem. And so, again, the biggest thing here is just being able to write that out. Read through this. We'll try to pick out some math terms. We'll try to understand what's going on with the situation. We have a man flying a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Okay, he's flying into a headwind. All right, so if he's flying into the wind, that means the wind is slowing him down. Okay, the wind is decreasing his speed. So when that happens, the trip takes him 2 hours, and then on the way back, the wind is blowing at the same speed, but this time it's blowing with him. Right? He's flying in. He's flying with the wind, so the wind is actually speeding him up. So because of that, the return trip only takes an hour and 12 minutes. And so they want to know two things. They want to know what is his speed in still air and how fast is the wind blowing. So he's flying the same speed, right? Both directions, but one way the wind is slowing him down, and so it takes him 2 hours, and the other way the wind is speeding him up, and so it's taking him less time. It's taking him an hour and 12 minutes. Okay, so they're asking about the speed in still air and how fast the wind is blowing. So these are our first couple of clues here. These represent the variables that we're going to create. And so we have the speed of the airplane and we have the speed of the wind. Okay, so the speed of the airplane and the speed of the wind. So in my problem here, when I go to set this up, this is assignment 3-3. This is problem number 8. And so my variables, I'm going to use the speed of the airplane. And so I'm going to say that that's A represents the speed of the airplane. And then I'm going to use W to represent the speed of the wind. Okay, and both of these speeds are constant, right? They don't change from the time he leaves to the time he comes back. He flies the same speed there, he flies the same speed back. The wind's blowing in the same direction, it's blowing at the same speed. So those two values won't change, but they are different values. All right, so let's look at what happens here. So we know to calculate how far he's going to go, right? We know that the distance that he's flying is 180 miles. But to figure out how far that airplane goes, like in terms of its speed per hour, like the total speed per hour, we're going to take the speed of the airplane minus the speed of the wind, okay, and multiply that by the number of hours. So we have 2 hours, okay, and the distance is 180 miles per hour. So, so if we look at our equation here, so we have, right? So we're talking about miles per hour and miles per hour, right? That's the speeds, okay? And we know that it takes him 2 hours. So it takes him 2 hours to go there. So what's happening here? So we know the distance, right? We know that the distance is equal to the rate times the time, right? So if I go, if I'm driving at a speed of 50 miles per hour and I drive for 2 hours, I know that 50 times 2, I'm going to go 100 miles. Okay, so we have distance is equal to the rate times the time. So we're going to apply a similar thing here. So we have to think about the overall speed of the airplane. So the overall speed of the airplane is the speed of the plane minus the speed of the wind. So A minus W. Okay, and we're going to multiply that by the by the time. So 2 and that's going to be 180. Okay, so in 2 hours, he goes this speed, right? The speed of his plane minus the speed of the wind, and in 2 hours, he goes 180 miles. So distance equals rate times time. So there's distance, and there's the rate, and there's the time. Okay, now on the way back, it only takes him an hour and 12 minutes. Now, we have a little bit of an issue here because if we talk about an hour and 12 minutes, that's not like 1.12 hours. There's only 60 minutes in an hour. So we have to think about that in either minutes or we have to think about that in hours. And since we're talking about miles per hour, I'm going to use hours. And we use 2 hours in the first equation. The second equation, we have 1.2 hours. Or sorry, 1 hour and 12 minutes. 1 hour and 12 minutes. So we have to figure out what that equals in a decimal, right? How many hours does that represent? So let's take a look at this. So we know that when he's going back, he's flying with the wind. So that means the wind is increasing his speed. He's still going to go 180 miles, but then this time the time is the thing that changes. And we know that it's an hour and 12 minutes. Right, 1 hour and 12 minutes. So we have to figure out, well, 12 minutes, how much of an hour is that? So if I said, well, there's 12 minutes and 60 minutes represents 1 hour, I can do that division and I would see that that is equal to 1/5 or it's 0.2. Okay, so 1 hour and 12 minutes is the same as 1 hour and 12 minutes is the same as 1.2 hours. Okay. So 1 2/10 of an hour. So that's going to be my time. So that's 1.2 hours. And so there I have my my system of equations. So distance, 180 miles is equal to the rate, which is his speed here, times the time for 2 hours. So in this case, the wind is slowing him down, so we're subtracting. It's a difference. And in this case, the second equation, he's going with the wind, so his speed is increasing, and it only takes him 1.2 hours. Okay, so now we have to go ahead and solve this. Again, this is solving by elimination. And so what I'd like to be able to do is to be able to just add those two equations together and make one of the variables disappear. And I can do that almost, right? I have a minus w and I have a plus w, but the problem is that it's multiplied by 2 and it's multiplied by 1.2. So in order to add those together, what I really want to do is I want to divide everything in the first equation by 2 and divide everything in the second equation by 2. And so when I do that, I get a minus w is equal to 180 divided by 2, which is 90. And then for the second equation, I have a plus w is equal to 180 divided by 1.2. So I'm going to grab my calculator here, divided by 1.2, and I get 150. So now I have a nice system of equations. It's all set up. It's all set up for elimination. I've got a negative w and a positive w. So when I add these two together, I get 2a is equal to 240. And if I divide both sides by 2, then I know that the speed of the airplane is 120 miles per hour. Okay, so the speed of the airplane is 120 miles per hour. And I know from the second equation that the airspeed and the wind speed added together is 150. So I know that 120 plus w is 150. So I know that w has to equal 30 miles per hour. So the wind is blowing at 30 miles per hour. The airplane's flying at 120 miles per hour. On the way there, the wind is slowing down the airplane. So its net speed is only 90 miles per hour. And it takes 2 hours and he goes 180 miles. On the way back, the wind speed is speeding him up So on the way back, he's going 150 miles per hour, right? And it takes him 1.2 hours to go 180 miles. Okay, so there's our two answers. The speed of the airplane is 120 miles per hour, and the speed of the wind, I kind of ran off the screen there, sorry about that. The speed of the wind is 30 miles per hour.